All right, so hopefully you have this handout in front of you, the one that you see on my screen. And we're going to try to work through some of these problems. Now, if you've done all the triangle math this week, then this should be really easy. We're just going to be applying all the triangle math to some specific situations. So if you read through the top up here, it says we've got two fundamental problem types with vectors. The first one generally has a vector or is a word problem where we need to draw the vector that is kind of directed somewhere between north, south, east, and west. So in other words, it's not going north or south or east or west, it's somewhere in between. And then our job is to find the magnitude of the two vectors that made the one that we see. So basically we're taking one vector and we're going to break it apart into two. And when we break it apart into two, our new vectors will be either north and south, or they will go east and west. So effectively what we're going to do is we're going to take, if you think about a right triangle and how a right triangle is drawn, there's usually two parts of it if we draw it on a grid that are east, west, and north, south. It's always the hypotenuse that's going to be off at an angle. So on your video, or excuse me, on your handout right now, there's a couple of sheets for you to work on. We're going to work on how to solve here. So again, we're going to remember that if they just give us one vector, this actually ends up being the hypotenuse, and we're going to turn it into a right triangle by adding the other two sides. So this problem number 2 has some things already drawn out for us. And so what we want to do is we're just going to complete the triangle and then use the boxes on here to figure out how much it is. So this AB down here was already done for you. And the way they got these numbers, it says the X component is 2.25 and the Y component is 0.25. So if we turn this AB into a right triangle, and it's going to be hard for me to do because I don't draw very well on this pad, and you could do this in two different ways. So I could draw a long line straight and then go up to the B, or I could go up to the B and then draw a long line. It doesn't matter which way you go, because if I do this, I'm going to try to see if I can not make it messy. If I go up here and then, yeah, that's awful. Hopefully you can imagine what a triangle is supposed to look like right there. And so it went up by one box. And if you'll notice the way that these boxes are, from here to here is 1, and from here to here is 1, and from here to here is 1. So this is a distance of 1. That means that each of these boxes is a distance of 0.25 because it's like a quarter. So if we divide this 1 into fourths, so each box is 1/4. So we go up one box, which will be equivalent to 0.25. That's where this comes from, because again, Y is going up and X would be going side to side. If we count how far we go left to right and count all the boxes, again, every 4 boxes is 1. There's 9 boxes. And so that would be 2 complete units and another quarter unit that's there. So again, remember, every box is equal to 0.25. So we can just count our boxes. We're just counting our boxes to get 2.25 and 0.25. And then we would use Pythagorean theorem to figure out the length that we're missing right here, because this is our 2 sides of our triangle, and this will be our 3rd side. So we would just need to do our a squared plus b squared equals c squared. These 2 sides would be our a and b. So once we put them in to our calculator, like 2.25 squared plus 0.25 squared equals c squared. Remember, when you get this together, that equals c squared. And like we did in the first unit, if something equals something squared, we usually don't want to leave it that way. We need to take the square root. So to go from c squared to c, we're going to end up taking the square root of that. Okay. Probably helpful if I just pop that up in Desmos real quick. See if I can get a Desmos calculator over real quick. If you already know how to do that, then you feel free to skip through on the video right here. And if you need help, you can continue watching. So if we did 2.25 squared, that shrink this up a little bit. And what do we have? Plus 0.25. And then we had that squared. One of the things you can do with your Desmos calculator, if you didn't know this, is instead of having to type this in again, if you click on answer, it'll just kind of paste that in. All right. But what we want to do is we want to take the square root of this. I'm going to go ahead and hit the square root button and then hit answer. And that's where the 2.26 comes from right here. that you see in your answer down there. All right. So again, we can draw it out and count the boxes to get the pieces in here. And then you're going to do your Pythagorean theorem to get the rest. There's a couple of them here that I don't say they're tricky, but you can't make a triangle out of them because in M, we can't really turn into two additional vectors because it is what it is. And the same thing with EF. So you're not going to be able to do Pythagorean theorem with the ones that don't like make a hypotenuse because they're just going down. So, so for example, in M, it doesn't have an up and down component to it at all. Right? So its Y component is going to be 0. So probably want to pause the video, see if you can work through and get the answers for these. I'll have most of them posted for you later. What you're going to see on the second page is more common to the types of word problems we'll have where there's not graphed out for you. So this first one says sketch the vectors A, B, and C, and then create a right triangle from this. Remember, when you do this, your original vector is going to end up being a hypotenuse. All right, and then we can use some trig to be able to do this. So if I read this, it says 2.65 kilometers at 40 degrees north of west. So what I want to do is marker. Just kind of sketch this out. It says north of west. If you've done your direction video, that means, remember, that means we're going to go west to begin with. And then north would mean my resultant vector is not going to be, so this will be to the west, right? And north would be this way. So if I'm going 40 degrees north of west, my resultant vector is going to be somewhere in between, and we don't really care if it's perfect or not, right? So sketch this out. And then what we want to do is to try to figure out what's the east-west component. All right, so this is going to end up being, we're going to turn this into a right triangle. And I'm going to sketch it out down here so you can see it a little bit better. Now, I've got an arrow this way and I've got an arrow this way, but basically what we want to do is to pick up one of the arrows and move it. And since we're talking about this angle, because it says north of west, so we're talking about this angle moving north from the west, what I want to do is I've already got these two sides of my triangle. I can just close it in on the other side, right? So this is west, and then this is my angle, and then I can put another one right here to complete the triangle. And if I label it, then I've got an angle right here, which is 40 degrees. And it tells me that it's 2.65. Now, again, the 2.65 is the hypotenuse, which is going to be this part right here. So that's our hypotenuse. When I'm looking for the east-west component, again, that's side to side. And since I'm talking about this angle, the east-west component means I'm solving for the adjacent side of our triangle. And then the north-south component is going to be over here. That means I'm going to be solving for the opposite side, right? So you've got your trig formulas in front of you. If we're trying to find the A and we've got the H, the A and A is going to be your cosine formula. And so remember, the formula is cosine theta is A over H. And we're trying to find A. And so we need to rearrange our triangle or rearrange our formula. If you need to sketch out your triangle, and if we did that, we'd have the A on top because it's A over H cosine. So if we're trying to solve for A, then I need to multiply these two together. So it's going to be the cosine of my angle, which is 40. And I'm going to multiply that times the hypotenuse, which was 2.65. So again, this is the same math you've been working on this week. It's just going to be applied to a word problem for us to be able to figure it out. All right, so once we have this, we can stick our stuff in the calculator. Again, we want to make sure we're using the scientific calculator. Looks a little messy on here. Let me get a new thing on here. So cosine 40, and we're just going to multiply that times 2.65. And I get an answer right here, which is 2.03. And that's my answer that would go there. And again, I ask you to show your math. So you could just put your formula in there again, cosine of 40 times 2.65, and it's going to give us our answer right here, which again is 2.03, or you could just round it to 2. Again, that should make sense. If 2.65 is our hypotenuse, then the two sides should be shorter, right? So this was approximately 2 kilometers. And then if you're doing the north-south, and here's the kind of easy cheat. If we're doing north-south, that means we're trying to find the opposite. So we got opposite and hypotenuse. And if you've got opposite and hypotenuse, that's going to be the sine function. Now, if you did all the math, what you would end up finding out is you do the exact same thing, except you just end up replacing cosine with sine. And that's going to end up giving you your answer. If you want to go through and make sure that you don't get things wrong, that's fine. But when you're doing these triangles, if you use the cosine on one, you're going to end up using the sine on the other. And it ends up being 1.7. You could have at that point used the Pythagorean theorem too, because you had two sides to get the third. So there's not always just one way to get to our answer. But we've got 1.7 on that. Okay. If you need to pause, rewind, if I went too fast with that, do what you need to do. If it did make sense, ask questions in class. But I'm just trying to give you the bare bones about how to do this. You do the rest of these the same way. Clear things off. So again, we would just draw them in different ways. And if you've done your directions, then if we've got west of south, that means we're going to be going south to begin with. And I'm going to have an 18-degree angle like right here. And this one says south of east. So that means we start to the east, right? And we're going to be going to the south. So I can just draw these two over there. And 28 degrees south of east would be an angle like that. All of these, you're going to turn into a right triangle. All of these, you're going to use sines and cosines to find your missing two sides. Okay. Now, I'm going to do one quick word problem as well, just to set it up for you, but the math is going to be the exact same thing. So some of these are going to be word problems like a cannon launches a cannonball into the air with an initial velocity of 20 at an angle of 30. But again, so just sketch it out. It doesn't matter if it goes left or right, but usually if we've got something like this, we've got the ground, which is kind of like our X, and it's going at 30 degrees above the horizontal. Horizontal means our flat horizon, left to right. And so we would just sketch it out, and it's telling me that this angle is going to be 30 degrees, and it's got an initial velocity. It doesn't have to be a distance when we're doing vectors, because a vector is anything that's got displacement in it. And so velocity does have a displacement in it, and velocity is a vector. So this is still going to be our hypotenuse of our triangle. And again, it says determine the horizontal and vertical components or parts of the initial velocity. So basically, I'm trying to say, how fast is it going this way, which is my adjacent side of my triangle that I'm going to complete right here. And then is how fast is it going up and down? And that means I'm trying to find the opposite. So all of these, you're doing the same thing, create a triangle, label it out, and then you're solving for adjacent and opposite on those. All right. So see if you can finish that one up. And additionally, see if you can finish up problem number 4 right here. If you need to take a break, take a break. I'm going to move on to the second side of the sheet and see if we can go through this. This one is the reverse, basically. Okay, so this is the second type of problem. This one, you're going to be given two components and then asked to make a resultant vector. All right, component generally means the parts, and the resultant's what we end up with at the end. We're going to solve these by taking some steps. Again, draw them out based on what you are being told. We want to turn it into a right triangle by adding a hypotenuse. And then, and I'll show you how to do this, because it's not just turning it into a triangle. We got to do one thing before we turn it into a triangle. And then we're going to use the Pythagorean theorem to determine the lengths. And then we can use an inverse tangent to get the angle that we need. So again, all math that you should have already done this week and practiced with. A couple of notes. Stone them here. If there's a vector or motion in the same direction, that means they just get added together to be more. This could seem obvious. So if I've got 10 and 10, that's 20. If they're going in the opposite direction, we subtract them. So if there's a vector this way and a vector back the other way, and they're on the same opposite direction, we're going to subtract them out. So if I'm running 10 miles an hour and there's a headwind like blowing in my face at 5 miles an hour, that's like 10 this way and 5 this way. So that's going to combine for a total of 5. It's just kind of like math on a number line. And we'll see an example of this as we get in here. So I'm going to work out some of the problems. I'm going to work out stuff here on the very first one, and then hopefully you can work out the rest of these. So the first part of it says a river flows at a speed of 12 meters from north to south. So again, if I start sketching these out, I've got a river and it's going 12 that way. A powerboat can move at a speed of 23 in still water. So it says, what's the maximum velocity of the boat going upstream? So it means it's traveling against the current. And so this is kind of what I'm talking about in opposite directions. So if my boat can go 23 this way and the stream is going 12 down, I'm just going to subtract those. Okay, so 23 minus 12 is going to give me 11 meters per second. Part B says, what happens if we turn it around? What's the maximum if it's going downstream? So that way they would be going in the same direction. So 12 and 23, add those together, that's going to be 35. So when we have vectors that are going the same direction, we add them. If they're going in opposite directions, we subtract them. Now C becomes the triangle part of this. If the boat was headed east across the river, so again, the river is, I got 12, and if the boat is going east across the river, remember the boat's going like this. If it's going east, 23. Now we've turned this into a triangle. One of the rules of turning these into a triangle is that the arrow part of your vector needs to be touching the beginning part of the other vector, because there may be some times where you're like, something goes this way and something goes this way. What we don't want to do is we don't want to draw the triangle this way, okay? Because what we want to do is we kind of want to put these two vectors together. And so what we need to do is kind of pick this thing up and we want to move it to the other side. So even if the original, if our thing, we'll think about drawing it, we always want to draw, we call this the head of the arrow and the tail of the arrow. We always want to put our vectors so that the tail and head kind of connect to each other. And then we would make our triangle this way. The resultant vector would go from where this starts to where the whole thing ends. So we just want to connect arrows to one another like that. So in this one, that's kind of what I'm doing. I've got my down arrow and I've got my right arrow. So the head and tails are connected. And then I want to get the resultant velocity, and that's where I'm going to draw another arrow from the beginning to the end. Right. So what do we do here? All right, well, we just made a right triangle. And so this right triangle has two sides to it, and I'm trying to find the hypotenuse, which, remember, the hypotenuse is going to be, if we use the Pythagorean theorem, that's going to be our C. So we can use Pythagorean theorem because we've got two sides of our triangle. We got a 12 and a 23. And we can use the Pythagorean theorem to figure out our third side, just like we did before. So I'm going to clear my drawing so it's not so bad. So I'm going to have 23 squared plus 12 squared. All right, so that's going to give me 673. That equals C squared. And remember, we need to then take the square root of 673 to get 25.9. Now, if you didn't take the square root and you got 673, hopefully you'll be like, that doesn't make a whole lot of sense. If I've got a side of a triangle that's 12 and 23, probably wouldn't have a 673. That's huge compared to the other ones. It should be slightly larger than your longest side, and it is. So it's like 25.9 would be our answer on this one. So that is the resultant velocity. Now, if we wanted to do a little bit more, which we probably should, is to figure out what this angle is. So we just got the answer for this one. I've already forgotten what it was, 25 point whatever. I'll go back and look at it in just a second. If we want to find this angle, all right, this is where we're going to end up having to use the inverse function. So another math thing that you should have done this week. So if this is 12 and this is 23, and we're trying to figure out what angle this is, then this becomes the adjacent side and this becomes the opposite side. We can use the tangent function to do that because tangent of the angle is opposite over adjacent. Remember, if we're finding the angle, then that's when we use the inverse button on the calculator. And we just need to put opposite over adjacent, which is going to be 23 divided by 12. So we're going to open the Desmos calculator back up. Right, so you'll notice again, the inverse sign is not up here to begin with. Excuse me, the inverse tangent is not up here. So we have to hit the function button to get that. So I'm getting a new line up here. So I just type in inverse tangent, and then I put 23 divided by 12. More space. Oops. And we get 62.4 degrees. So that's what angle this would end up being right here. So that's all we got to do. Inverse tangent, opposite over adjacent. That's going to give us the angle that's being made right here. So if you were asked to get the angle, which often we are, that's the answer we're going to get right there. That answer was 62 degrees, right? Approximately. And then we would want to do the direction part of it. And then another thing you should have done this week. So the way we do our direction, it's one direction from the other one. So we're talking about this angle right here. So this is south and it's moving towards the east. So we would say that this is 62 degrees east of south. Okay. That would, since we're using this triangle, that's kind of what we would need to do with that. All right. So I know it's kind of a lengthy video, but I want to go through some example problems with you. You need to practice working on the rest of these. And most of these other ones, again, you want to sketch out and turn them into a triangle. The only semi-tricky one down is the very last one. And if you'll notice, it says it goes 23 blocks north and then 20 blocks south. Just think, remember, those are opposite directions. And so ultimately, they're going to kind of cancel each other out. So instead of saying 23 blocks north and 20 blocks south, we would subtract that and it would just end up being 3 blocks north in total because it comes back. Remember, we're doing our displacement. So when you draw this and you sketch it out, you should have a side that's 12 and a side that's 3 on your triangle. Need help with that one, ask me about it. Practice these. Should have answers posted in the classroom for you to double check and see how you're doing on these. All right. Thanks for sticking with me. I know that was a bit long, but I needed to go through some examples on this.